Hello, this is Nathan with Complete Water Solutions, and today we're going to be covering water softener salt consumption. I think some of the biggest questions that I get in our industrial softener applications are, am I using too much salt? Or I feel like I'm using too much salt. How much salt should I be using? And how can I not fill my brine tank this often? I think that's some of the key questions that we get pertaining to water softeners. And then obviously the environmental impact that sodium chloride has. And we'll talk about that a little bit as well today. But let's dive right into it and let's take a look at what we have to talk about, which will be basically softener systems, salt consumption, and kind of how to calculate some of that. And then as well as things that we can do to potentially reduce that. So let's dive right into it. Again, my name is Nathan with Complete Water Solutions. And a little bit about me is that I have been with Complete Water now since 2013. I've been in the industry for about 27 years now. I'm a power plant operating engineer. I've had tons of training on different types of equipment, different manufacturers. A lot of it's been hands-on. Some of it's been through formal education in class. I've had some publications. I've done some stuff for the water quality magazines that are out there, just helpful things, as well as some tips in our industry, things that can help make the ease of doing business easier. Some of the things that we do here at Complete Water Solutions, we focus primarily on the mechanical filtration side of stuff. So softeners, DI, reverse osmosis, dealkalizers, RO systems, high purity, you name it. We do a lot of that here in the marketplace. We do everything from engineering. We build custom equipment, PLC control operations, installation, startup, training, routine maintenance. Even if we didn't sell it or install it, we can help you service it or get you parts for it. So not a problem there. Some of the things that we do work on are listed in this as well. So let's start diving into the basics, right? How does hardness even get into the water? What is hardness? And we'll kind of talk about that real quickly. But I think a lot of us have seen this, something similar to this as far as the life of water. Water basically is rained down, right, from the sky and kind of just percolates through the ground. And as it's percolating through the ground, you will pick up things like calcium, magnesium, iron, stuff that can get dissolved easily, silica, and among many other things. Some interesting facts about water. This number has changed a little bit over the years, but about 97% of the Earth's surface is in ocean. Ice is about 2.1%, and underground is 0.6%, and lakes, rivers, and streams are about 0.01% of all water makeup. There are about two types of water in the world that we classify them as surface water, rivers, lakes, and streams, and then groundwater, which as well as in aquifers. And below you'll see there's some interesting characteristics, right? With surface water, you'll typically have lower hardness, higher organic rates, usually lower conductivity, and you'll tend to have more pollution, right? Runoff from vehicles and what have you, fertilizers, chemicals, stuff like that will usually find it easier to get into surface water versus well water, where you'll tend to have higher hardness, low organics, high conductivity, and less pollution typically. Again, some of those things may vary a little bit. Water contamination in the industrial marketplace isn't necessarily things like nitrates or radium or chemicals that you might find in the water. For the industrial marketplace, contamination can be hardness. For pharmaceutical, for USP purified water systems, right? It could be TOC, could be connectivity, could be hardness, could be iron, could be silica. There's different things that can form different types of contamination or be classified as contamination. And so that is something to kind of keep in the back of your mind as you're thinking about, okay, can I do without water softeners, or what can I do to help mitigate the use of water in my facility? It might be just that the contaminant that you have may just need a different type of treatment to get around that. But we'll talk about that a little bit here. Types of contamination, here we go. Kind of just going through it, right? Biocontamination, chemical, oil, gases, and each one of these might have a different way of treating it. And so we'll talk a little bit about that. But basically, what kind of contaminants do you have? Well, the best way is to test and repeat that test, because water quality will change over time, and that is a known fact. It can change slightly, or it could be greatly, depending on water tables and all sorts of different things that can impact that water quality. So what is water hardness and how does it get there? Well, water hardness is simply when we talk about that in our industry, it's really just calcium and magnesium are the two things that really make up water hardness, is what we consider it in general. And that water hardness, again, if we go back to that cycle of water, it just, as it percolates through the ground, it just picks up, it passes rocks that are full of calcium and magnesium. And calcium and magnesium are two minerals that are easily dissolved by water. And so that's how we get it there. And then as you can see in these pictures here, bottom left-hand side is a pipe that's got calcium carbonate in it. The middle pipe has calcium carbonate, magnesium, as well as some iron. And then the right picture is actually an RO membrane that was scaled up due to calcium as well. So we're going to talk about softeners right today, about calcium and magnesium removal or exchange. And the most common way is cation resin, or water softener resin as we know it. Water softener resin is basically a plastic bead. It's basically circular, and it will hold a negative charge. Just by the way that it's manufactured, it holds a negative charge on its surface. And that negative charge is what attracts calcium magnesium. Calcium magnesium is positive, and your resin bead is negative, so it's just going to stick to the surface of that resin bead. So, and here's a picture that kind of looks a little bit better about it. But your water softener system will have a bunch of this resin inside of its tank, and the resin itself, if you look at this picture here, you'll see a good explanation of it. But as your calcium magnesium hard water flows through the resin bed or the resin beads, it will put on a calcium ion and then bump off a sodium ion. So if we look at the periodic table of charts regarding calcium and sodium, you'll find out that calcium and magnesium have a higher molecular weight or ionic atomic weight than sodium does, and so it will have a better affinity to stick to that resin bead than the sodium will. So sodium will get bumped off, calcium magnesium will stick to the surface. So your softener system has so many resin beads in it, right? And after so much hard water is passed through, it's removed as much sodium ion as it can, and it's deposited as much calcium and magnesium on the surface of the resin bead. And that's when we consider the bed to be saturated. And at that point, your bed will no longer produce what we call soft water. And at that point, you have to regenerate. And during that regeneration process is when you start utilizing that salt, right? And so the first step, kind of bounced screens there, sorry about that. But the first step, when your softener becomes exhausted and needs to regenerate, usually the first step in most industrial softener systems is going to be backwashing. And backwashing is where we take it sounds exactly what it does, is we're reversing the flow of the softener system. And as you can see down in the picture below, it's more like a residential or maybe a smaller industrial softener system with the top mounted valve, but we're reversing the flow. The water is going down that center tube, going out the sides and up the side of the tank, and that's creating that backwash. This backwashing serves two purposes. It serves to get rid of any particulate that might be on the top of the resin bed, and then it also expands the resin bed. And it expands it so that way it's not compacted anymore, because when you got downward flow, it compacts, and now that we've backwashed, we're expanding it. And when we expand it, it allows the resin beads to be not as compacted with each other, so that during the brine draw cycle, the salt water can actually get all the way around the resin beads. That sodium can get around the resin beads, helping exchange that calcium magnesium off for the sodium ions. So usually backwashing happens anywhere between 5 to 15 minutes. Has usually been a pretty good general rule of thumb. So here we go. Here we go. We're right on to the brine draw cycle, which is the second step. During the brine draw cycle, we're bringing in concentrated sodium solution from your brine tank, and it's rinsing over the resin beads. And as we're rinsing over the resin beads in super concentration, we're able to bump the calcium and magnesium off. So we talked earlier, right, that the molecular weight of calcium and magnesium, or the atomic weight, is heavier than sodium. So in order to remove or bump that calcium magnesium off, we have to bring sodium in a concentrated form to help dislodge the calcium and magnesium off the resin beads, and then put the sodium ion back on. So standard brine draw cycle is about 60 minutes, give or take. I've got some customers that are 90 minutes. I've got some customers that are 40 minutes, and it's give or take. And usually about the first 20 minutes or so is when you're drawing the brine out of your brine tank, your salt silo, wherever it may be. And the first 20 minutes is where you're drawing that brine out. And that brine is then slowly percolating through the bed the remaining 40 minutes of the brine draw cycle. The fourth step we have is fast flush. And this basically recompacts the bed and puts the softener in a standard flow pattern, but we're just blowing water out to the drain there, dumping water out to the drain. And during this time, we're just removing any remaining potential sodium water or higher conductivity water left in the resin bed. Usually you don't have much, but there might be just a little bit. Fast flush cycle, about 5 minutes long. Again, got some customers that are 10 minutes, some that are less. And so it's about 5 to 10 minutes usually is a ballpark range where you're going to be at on that. So salt usage during the regeneration, here we go. We're going to do the induction slide. So again, residential is going to be different than commercial and industrial systems. Residential will usually be about 6 pounds per cubic foot, 6 to 10, usually right around there. And in industrial and commercial, because we don't want any hard water, we can't have 1, 2 ppm, 3 ppm, can't have 17 ppm. We have to have that higher exchange capacity, and so we'll tend to do a little bit, usually about 15 pounds per cubic foot. We'll talk about that. But again, not all systems are the same. Some may be equipped with different media, so knowing your system can be helpful as well. Some may have different mechanical devices on them. I've got some customers that are using salt silos and brine tanks, and so it can vary all over the place. And some may regen differently. And we'll talk about that as one of the salt saving opportunities as well. So, all right, so let's dive right into some useful numbers here. And again, this will be, some of these slides will be available for you to click in the link below to be able to download some of these slides, just so you can have that information. And we'll also have an Excel and some test kits that we use in our field to help kind of do some of these efficiency studies. So standard industrial softening is usually right around 15 pounds of salt per cubic foot of resin. Will usually one gallon of water or brine water that's inside of a brine tank will hold about will dissolve about 2.67 pounds of salt. So it's kind of good to know. You can kind of get an idea how to start calculating, like, how much water do I need in my tank, and this, that, and the other. You can kind of get through some of that. And so it's pretty good, helpful information. So let's go through some salt usage estimate calculations. And this is kind of just a general estimate. And so we're going to plug in some numbers here just so we can help figure out or understand the math a little bit better. And this one, we have a 25 cubic foot softener, which will usually equals out to 750,000 grain capacity, or 750,000 resin beads inside the tank. 20 grain hard water. So this could be well water. And so if we take that 750,000 grains divided by 20 grains, we'll get about 37,500 gallons of water in between regenerations. And so we're plugging in here that we're going to use about 112,500 gallons of water per day, and that equals out to 3 regenerations per day. All right, so this is what we're going to use to kind of go through some of these calculations as we move forward, but you kind of get an idea of how you would use this equation to figure out how much salt your softener system will be using based off of your water usage, right? So you have to know your water usage, you have to know the size of your softener system, and you'll get an idea of about how much salt you will end up consuming, and whether or not if you're consuming more than that or less than that, and you can kind of get a better idea of your efficiency of your system. So 15 pounds of salt times 25 cubic feet equals 375 pounds of salt per regen, or 141 gallons of brine per regen. And if we use 375 pounds of salt, we're regenning 3 times a day. We're going to use about 1,125 pounds a day of salt, right? So now you can kind of get an idea of how much salt the softener is using. Now let's talk about some ways to reduce salt, right? Salt consumption, and we're going to dive into why brine studies are important. And I noticed that I did brine study, so I do apologize about that. But we'll talk about resin replacement or testing. We're going to talk about brine reclaim. That's a pretty popular system that's in use today. We'll talk about salt-saving resin technology that's out there. Hardness monitors. Why would we use those potentially to help reduce sodium usage or salt usage? Upflow regeneration, again, which is pretty commonplace in a lot of residential equipment today. And the removal of some items on soft water, some thoughts behind that, and maybe the areas that you could look at that can obviously help reduce your salt consumption as well. And then other pre-treatment equipment, some other thoughts or food for thought. Maybe it might be right in your facility to be able to implement some of these things, and we'll kind of dive into it. So let's dive into brine studies. So brine studies are commonly known as a brine elution study. You might hear it referred to, and it's the study of brine concentration in the waste or the drain line of your water softener system during the regeneration cycle or during the regeneration process. And we usually do this during the second portion of the softener system, which is that brine draw, slow rinse phase. And the items that you're going to need for this are going to be a graduated cylinder and a salometer. And both those items, by the way, we put a link to our website to be able to purchase those items if you'd like. So let's talk more about this brine study. So during the brine study, you're going to be taking grab samples, and we recommend doing it every 5 minutes during the brine cycle. And then using an Excel or Google Sheets, you're able to kind of chart this out, as you can see that I've done here. And you can see that there's a difference between the two units, right? A little bit of a difference. And so this was kind of helpful in our troubleshooting. It's a good idea to do one on each of your water softener systems, whether you have 2 or 3 or 4 or 5 units. The reason being is because maybe you've got 2 that are running really good or really poorly, and you can help make those adjustments on each one to kind of figure out, or it could be a mechanical issue, right? And you can kind of dive further into that to see what's going on. Here's what we do when we chart out our brine studies. As you can see, this is an elution study here. We graphed it out, right? So you can kind of see, where our curve is at and how things are running and operating. It's a pretty nice tool to utilize. By the way, I will put a link in the description as well for this Excel spreadsheet that you can use on your own. Feel free to use it. It's already pre-set up for you. So all you got to do is just plop in the information and be able to go. Brine studies. So here's another one. Many standard downflow regeneration softeners like to get a maximum exchange capacity. Basically, how to achieve this is in the world of water conditioning, it's been commonplace or known through years that you want to hit 30% salinity at the drain for about 30 minutes. You want to see 30 minutes of 30%. And it may be, 25 or 20 minutes of 30%. And, you might be at maybe 25 or 22 on the front end, and on the tail end, the same thing, which is fine. You're still going to be pretty darn close to that 30 for 30. The WQA, Water Quality Association, published this in some of their training materials, that this has been kind of an industry standard, and it's led to the most exchange capacity out of your resin bead. Not necessarily the most efficient, the most exchange capacity. So brine studies can also help you in determining whether or not if you're over brining. right? And overbrining could be causing you to utilize more salt than you need to for your regeneration. So shown here in a graph, you can see one of our softener systems is well over that 30 for 30, 44%, 42%. I mean, that's pretty high up there. So that would need to get adjusted as well. So overbrining, like here, we just did a quick calculation of our overbrining. So overbrining, we're using 18 pounds per cubic foot. So in a year, we were using 492,000 pounds, whereas our standard brining at 15 pounds per cubic foot, we're only using 410,000 pounds, right? So that's like an 82,000 pound difference. That's a lot of salt. So this is a great tool in helping identify if you're overbrining or underbrining to be able to get the best capacity out of your softener system. Resin replacement. This one is just a general rule of thumb, but water softener resin, I've seen it last as minimal as 7 years. I've seen it last as long as 25 years with some customers. And it wasn't that it went bad overnight at year 25. What happened was at maybe year 10 or 12, we started seeing significant reduction in capacity. And that significant reduction in capacity caused the softener system to have to regenerate. So in our example earlier, we were able to get 37,500 gallons of water in between regenerations. Well, maybe at year 7, we're down to 35,000 gallons. Maybe at year 12, we're down to 30,000. Year 18, we're down to 24,000 gallons of water in between regens. Well, at some point, the cost of the salt and the wastewater that you're using for the regeneration process, as well as mechanical wear and tear on your softener system, it just makes more sense to go ahead and replace the resin because it's not going to come back. And so you're better off just to go ahead and replace it and be done with it. Some systems may require annual top off. Some FDA or food and beverage facilities may require you to do it annually, or potentially get it done sooner. One of the things you can do is have your resin tested. We'll talk about that here in our next slide here. So you can have your resin tested, right? You can remove the valve, the manway, whichever way you have to access your resin, and you're going to want to grab a core sample. And to grab a core sample, the best way to do it is to take a pipe, like maybe a 1/2-inch pipe or a 3/4-inch pipe, stick it down inside the bed and put your thumb over that pipe, creating a vacuum, and then pull up and then put it into a container or however you're going to ship it off. But that core sample will help give you an idea of how your resin is doing, what the life expectancy of it is, and potentially any problems that you may be having. Resin tests are a great way to kind of gauge the life of your resin or how it's performing compared to new resin. And so that's pretty good. While you've got the softener system open, great time to check the freeboard. So freeboard is basically the space between the top of the tank or the weld, and we'll show you the next slide of that, and where the resin bed is at. So we talked about backwashing, right? And so in this slide, you can see on a fiberglass tank, that freeboard is from the top of the tank, and on a steel tank, it's from the weld down to where the resin bed is at. When you replace your resin, or when your softener system was first installed, this was a great tool. You make sure you mark the freeboard. We do it all the time. Mark the freeboard. And as the years go by, when you open up the tank to go grab a sample or just check the freeboard, or even mark the outside of the tank where the freeboard level was at, when you go to recheck it, if you're 2, 3, 4 inches short and you did your resin test and the resin came back good, you could just potentially just add some more resin to the tank and top it off so you can gain back your capacity. So that freeboard is important. If you have too little space of freeboard during your backwash cycle, you'll just blow the resin outside the tank. If you have too much freeboard, you've lost some resin, right? And might be the reason why you've got some capacity run issues. So something, food for thought. take some freeboard measurements when you replace your system or when you replace the resin media, so you kind of get an idea. If you don't know what your freeboard is supposed to be, call the manufacturer. They'll help you get that information. You can certainly contact us as well. We'll try to give you as much information as we can. Brine reclaim. So brine reclaim is pretty popular. It's utilized now, more commonplace than it was maybe 10, 15 years ago. And so a lot of systems are sold with either brine reclaim or salt saving resin, which we'll talk about in one of the upcoming slides. But brine reclaim is basically where you take a portion of your brine. Remember when we were doing that brine study and how we were graphing it out? We're going to take a portion of that brine and we're going to reclaim it back to the salt tank. And we're doing this because we're going to, that water is about 30% salinity, right? And so we can recover some of that and not have to dissolve as much salt for the next regeneration. So brine reclaim, a rule of thumb, at least this is for us here at Complete Water Solutions, we don't want to recover all that brine. Especially the beginning portion of the brine regeneration cycle, you're going to be really concentrated with calcium and magnesium during that portion of it. And so we tend to tell people, hey, you're better off reclaiming kind of like the back half of that high concentrated brine because you'll tend to have less calcium and magnesium in it. Again, it can be counterintuitive. If you reclaim all the brine and you've got too much calcium and magnesium in that water, it'll be counterintuitive to that regeneration cycle, and you may just end up short cycling your softener system from being able to produce as much water because you've got too much calcium and magnesium in that brine solution. So it may just have that reverse effect, like I've said here in the slide. So you may want to take that into consideration. Example of a drawing of a brine reclaim. It's pretty crude, guys. Sorry about that. I did it on Word because I was trying to get this out. But you can see that we got two softeners there. We got a waistline, and we've got two blocking valves, right? So during that regeneration cycle, we'll block off the water going to the drain, and we'll open up the valve going back to the brine tank to help reclaim some of that water. There are some controls and other things that are that you want to incorporate into that, but this is kind of just an idea of how that brine reclaim will look. Salt saving resin. So salt saving resin has been around quite for a while now. There are different forms of salt saving resin. Some are fine mesh, among many others that are out there. But for us, we utilize Purolite, which is a manufacturer. They make an SST60. And it is salt-saving technology. It is a resin that's manufactured in such a way that you can use up to 2 to 4 pounds less salt per cubic foot of resin. Not 2 to 4 pounds of salt per regenerated, 2 to 4 pounds less. So what does that look like? So down here, I ran some calculations out for you guys. So you can see with our standard brining, like we talked about in the beginning here, down at the bottom of the page, we've got 15 pounds of salt per cubic foot, right? When we regenerate, we're going to use 375 pounds of salt per regeneration, not per day. So I do apologize about that mistake there. And then up here, we've got our salt saving resin. So I just chose right in the middle. We're going to use 3 pounds less salt per cubic foot. So we're going to use 12 pounds per cubic foot. So we're going to use 300 pounds of salt per regen. Well, if we're regenning 3 times a day, that's 900 pounds a day versus 1,125 pounds a day. And then down here, if you times it by 365, you can see a pretty huge difference between the salt saving resin and the standard resin as far as when it comes to salt consumption. So pretty huge numbers there. You times that out over a couple of years, your payback's going to be there without a doubt. Some additional benefits of salt saving resin, which a lot of people don't realize, not always talked about, but you actually get better iron removal. Believe it or not, the way that resin's manufactured, especially when it comes to SST60, you get better iron removal off of it, tend to have lower rinse requirements, lower leakage on all regenerant levels. So you'll tend to have lower leakage towards the end of the bed, and then less sustainable to fouling. And then it's more resistant to oxidation. What does that mean? So when you have chlorinated water source, you have an oxidizer that's already in it. So if you're on a municipal supply, or maybe you guys chlorinate coming into your facility, it's more resistant to breaking down because chlorine will break down resin beads. So it's more resistant to that. So you might get a little bit longer life than just using a standard resin. So it's something to take into consideration. All of those are obviously going to impact the overall system performance. So uh, great product. Definitely recommend as an option to Brine Reclaim that this might be another benefit for you as well, or another option for you. Hardness monitor. So we talked about this earlier. So, hey, how can I use a hardness monitor to potentially reduce my salt consumption? And what it comes down to is that you can pretty much set your water softener out to the full bed, right, until it's exhausted. And you could use the hardness monitor to potentially trigger the regeneration cycle for that softener system. This works great in locations where you might have multiple wells. Maybe a municipality has multiple wells, and those wells are all different as far as the quality is concerned. I've seen this happen before. Some places we do work at during the summertime, the hardness is around 10 to 12 grains per gallon coming in. And then during the winter time, their hardness shoots up to 28 grains per gallon. Huge, huge difference. And so without the hardness monitor, we would just be setting the softener system for that 28 grains per gallon, even during the summer, because we didn't want to run into hard water issues. So now that hardness analyzer, it's going to monitor the effluent of that softener system. And once it sees hardness, then it triggers the softener system to regenerate. Now there's no more, if the water quality incoming changes, it's not going to matter. That hardness monitor is going to be able to pick that up and not be a problem. So here's some Carmen hardness monitors. There are other manufacturers out there. The two most that we've had a lot of experience here at Complete Water Solutions is the Waltron 6051, great product, and as well as the Hawk SP510, and then they also have the 6000, I believe, for hardness analyzer as well. Both great products. Both have positives and negatives to them. Not going to dive too much into it, but again, one of those great tools to have to try to extend your bed output. Upflow regeneration. This isn't as commonplace in the industrial marketplace. Upflow regeneration, in my 27 years of doing this here in the Midwest and throughout the United States, I have found maybe a handful of places that are actually in the industrial marketplace that are actually doing upflow regeneration. And upflow regeneration is exactly how it sounds. So most water softeners are downflow regeneration. Pretty much on that left-hand side, the brine water is going through the resin bed on the outside. Upflow is exactly how it is in picture number 2. The brine is actually coming down that center tube and going out the outside of the tank, going up. And that upflow regeneration has positives to it. You can potentially use less brine in order to hit that. So you can get a little bit less brine concentration. So instead of 30%, you might be able to knock it down to 20%. So you might be able to use less salt in order to get the same regenerant or capacity removal out of your softener system. So warning on this one, I've read several posts, and I've also dealt with this before firsthand, especially on iron water. Not a good idea. If you've got heavy sediment or tannin, you may need to look at other things if you want to convert your softener to do this, you may need to look at other stuff upstream in order to handle some of that. Otherwise, it's not good on those types of waters. Remove items on soft water. Here's one, a lot of plants look at right off the bat to try to reduce salt consumption. Hey, what's one way that we can do that? Remove the items that are in soft water. Maybe you don't need it for your toilets, your sinks, maybe some things like cooling towers. And again, talk to your water treatment professional. If you don't have one, we'll try to find one for you. But talk to your water treatment professional and the equipment manufacturer. You need to figure out what's the highest hardness level you can go in that piece of equipment. Maybe there's other factors too that can compound on that. But like maybe a cooling tower can use a lot of water. And so you may want to consider, maybe you can switch the chemical program and do acid or something like that to try to mitigate from having to use softened water on the tower. So some food for thought, things that you can look at. Other methods to reduce soft water consumption. We have done this quite a bit in our marketplace here. Is put actually RO or nanofiltration upstream, or to basically take care of the whole plant. So nanofiltration is also known in the industry, or commonly known as the soft water membrane. Nanofiltration can help remove things like calcium, magnesium, and it will take care of that aspect. It's not as tight as RO, but it's the next one down or up from RO, and so it can help reduce some of that calcium and magnesium deposit. Reverse osmosis, this is most commonplace. What we utilize, we've done quite a few of these systems where we put an RO system upstream, or we've done RO for the entire plant, and anything that might need some additional iron removal, or not iron removal, sorry, hardness removal, we may put a polishing softener system in. So an RO system will remove about 95% of the hardness in the water. So if you have 100 ppm, we're going to keep this real simple. If you have 100 ppm coming into your facility, you may remove 95% of that and be left with 5 ppm of hardness left over. Maybe that's great for the entire facility, and you can get away just with 5 ppm. Maybe for your boiler, you just need to add a polishing softener system in. It'll be a smaller softener, won't regenerate as often because you've removed the majority of that hardness prior to the water softener system. This has the biggest impact when it comes to salt reduction and chloride reduction, and it may be right for you. It may be something you want to take a look at for your plant or your facility or your process. So here I've done some calculations for you. We just did a real simple one here. This was actually a customer of ours. We had feed water hardness of 121 ppm when we put the RO system in, and we've been maintaining it now for quite some time. The hardness coming off the permeate isn't been anywhere between 2 ppm on upwards to 10 ppm. Usually once we hit the 10 ppm mark, we know it's time to clean it. And our boiler annual usage is right around 30 million gallons of water is what they've used. Before, when they had the water softener system, they used to get 90,000 gallons in between regenerations. They used 450 pounds of salt per regen, and then their wastewater per regen was 1,315 gallons of wastewater every time it regenerated. They did 342 regenerations a year. They used 153,000 pounds of salt, and they wasted about 450,000 gallons of water. I know it's a little bit. So that's quite a bit that they were using. And so now when we put the RO in, that softener system capacity dropped, or increased, I should say. So instead of 90,000 gallons of water in between regens, we're now getting 300,000 gallons of water. We're only using 75 pounds of salt per regeneration, and we're only wasting 228 gallons of water between regenerations. And you're like, well, how is that? Well, because we are able to put a smaller water softener in. Because the majority of the hardness is being removed by the RO system, we were able to put a smaller softener system in that reduces the waste and also reduces the salt needed per regen. But another benefit that we don't really talk about too often is the maintenance. Bigger water softeners have typically higher maintenance costs, right? You got bigger valves or bigger components that you have to replace. Well, if you got a smaller water softener system, you might have less components or smaller components that need to get replaced, and typically they'll cost less. So estimated annual usage post RO, so this is a post softener system. We're going to regenerate about 103 times. So we're already down. If we look at our previous slide here, we're at 342 regenerations. Now we're going to be down to 103. So annual salt usage is 7,725 pounds, and our estimated wastewater is only going to be 23,000 gallons, 23,500, right? Round up. And you can see that's a pretty huge substantial impact between these numbers here. Sorry, I'm jumping on the slides here. These numbers here, right, at 450,000 gallons of waste and 153,000 pounds of salt, or 154,000 pounds of salt. That's a pretty substantial number. So here's where your savings is coming, right? 146,000 pounds of salt we're going to save, and we're going to save 426,000 gallons of water. That's a pretty substantial savings. So you may want to consider RO up in front of your softener system, or potentially doing the whole plant, or maybe just for your boiler. Some things that you may want to consider. So the last thing that I want to talk about was the environmental benefits. Chloride or salts, once salts enter the environment, it doesn't go away. It ends up in our lakes, rivers, and streams and wetlands. And chloride from salt degrades freshwater ecosystems. It only takes 1 teaspoon of salt to pollute 5 gallons of water to a level that's toxic to native aquatic organisms like tadpoles and among salamanders, or some of the ones that they do affect. Salt can stress plants, animals, and that have been adapted to the freshwater environment. And it's just not great. So, in a lot of states here in the United States, we are, looking for ways to reduce salt consumption, and looking for ways with that salt, you're reducing chloride. For every pound of salt, 67% of it is chloride. And so we're looking for ways to reduce that kind of stuff. And so all the stuff that we talked about up in the previous slides were ways to try to reduce some of that stuff. Here's some stuff. This was Bill Hintz, University of Toledo, did a study regarding, I guess this was a tadpole, or I can't remember what this was, what exact fish this was, but as you can see, there was a difference between the high road salt, or aquatic life that had been exposed to higher salt concentrations versus aquatic life that had been not exposed to high salt concentrations. So just things to think about when you're looking at ways to reduce this. You're not only reducing it for the money savings, but you're also reducing it for the environmental impact, and potentially even some safety, right, from loading salt and stuff like that. So it should help overall. But yeah, here you go. This was the studies. Oh, it's rainbow trout, and it's right there on the slide. So hey, you might want to read, right? But here we are. It did have some impact. So just some food for thought. You're reducing the environmental impact as well when you're reducing your salt consumption. Guys, I'm going to close this session out. I say thank you for sticking through this far in the video. Hey, if you have a moment, please click the like and the thumbs up button. It helps me. It helps the Google algorithm to be able to determine, hey, this might be helpful for other people as well. Hey, don't forget to check out our website. There's going to be links in the description below regarding our website, and there's stuff for RO troubleshooting. We also have a lot of information up there, just helpful information regarding RO systems, water treatment systems, iron filtration systems, and it's technical help. Right? It's tech tips. So it's not just jobs that we've done, but it's also stuff that can be helpful in helping design your system or helping maintain your system. We have a spot for RO information. It's under our resources tab. Don't forget to take a look at that. We kind of cover RO system theory of operation, troubleshooting, among many other things. We have water conversion factors or mathematical equations on our website as well. And then our blog. Check out our blog. We tend to post content like this and other helpful information on our blog. Don't forget to subscribe to our website or create an account on our website, because you'll be updated when we do release new blog posting. Don't forget to check out our YouTube channel. You may have landed on this video through our YouTube channel. So please don't forget to click and hit the like button and subscribe button. And if you could do me a favor, forward this off to other people that might find this helpful. I appreciate it. Again, my name's Nathan with Complete Water Solutions. Hey guys, sorry about that. My audio just dropped out of my video, so I'm doing a voiceover recording right now. But hey, listen, if you need some help, please feel free to give us a call toll free at 855-787-4200, or you can email us at info@complete-water.com. Again, that's info@complete-water.com. And as always, have yourself a great and